Chapter 1, Introduction to Corrosion and Cathodic Protection. Corrosion is a natural process that occurs when metal reacts with its environment, resulting in the deterioration and degradation of the material. This process can cause significant damage to structures, equipment, and infrastructure, leading to costly repairs and maintenance. Cathodic protection is a method used to prevent or mitigate corrosion by controlling the electrical environment around a metal surface. In this chapter, we will explore the basics of corrosion science, including the types and causes of corrosion, and introduce the concept of cathodic protection as a way to combat this destructive process. Section 1.1. What is corrosion? Corrosion is a natural process that occurs when metal reacts with its environment, resulting in the deterioration and degradation of the material. It is a common and costly problem that affects a wide range of industries and applications, including transportation, construction, energy, and manufacturing. There are many factors that can contribute to corrosion, including the type of metal, the presence of oxygen, moisture, and other corrosive substances, and the temperature and humidity of the environment. Corrosion can take many forms, including uniform corrosion, pitting corrosion, crevice corrosion, intergranular corrosion, and galvanic corrosion. The effects of corrosion can be significant, including reduced strength and structural integrity, increased maintenance and repair costs, and decreased safety and reliability. In order to prevent or mitigate corrosion, it is important to understand the factors that contribute to it and implement effective corrosion control measures. Cathodic protection is one such measure that can be used to protect metal surfaces from corrosion. Section 1.2, Types and Causes of Corrosion. Corrosion can take many forms, depending on the type of metal, the environment in which it is exposed, and other factors. Some common types of corrosion include uniform corrosion. This is the most common type of corrosion and occurs when a metal surface is uniformly attacked by corrosion over its entire surface. Pitting corrosion. This type of corrosion occurs when small, isolated pits or holes form on a metal surface as a result of localized attack. Pitting corrosion can be particularly destructive because it can weaken the material and create stress concentrations. Crevice corrosion. This type of corrosion occurs in confined areas or crevices where the circulation of oxygen and other corrosive substances is restricted. Crevice corrosion is often caused by a combination of chemical and mechanical factors. Intergranular corrosion. This type of corrosion occurs along the grain boundaries of a metal and is often caused by the presence of impurities or defects in the material. Galvanic corrosion. This type of corrosion occurs when two different metals are in contact with each other in the presence of an electrolyte, such as water. The more noble metal, less prone to corrosion, becomes the cathode, while the less noble metal becomes the anode and corrodes more readily. There are many factors that can contribute to corrosion, including the type of metal, the presence of oxygen and moisture, the presence of corrosive substances, such as acids or salts, the temperature and humidity of the environment, and the presence of mechanical stress. Understanding these factors is important in order to prevent or mitigate corrosion through the use of corrosion control measures such as cathodic protection. Section 1.3, Introduction to Cathodic Protection. Cathodic protection is a method used to prevent or mitigate corrosion by controlling the electrical environment around a metal surface. It works by applying a direct current to the metal surface, which causes a shift in the electrochemical reactions that occur on the surface. This shift in reactions reduces the corrosion rate of the metal and can help to prevent or slow the deterioration of the material. There are several methods of cathodic protection, including galvanic protection, impressed current protection, and sacrificial anode protection. Each method works in a slightly different way and is suited to different types of applications and environments. Cathodic protection is used in a wide range of industries and applications, including pipelines, storage tanks, offshore platforms, ships, and buried structures. It is a highly effective corrosion control measure that can extend the service life of metal assets and reduce maintenance and repair costs. In the following sections, we will explore the principles of cathodic protection in more detail.